So now we discuss how to represent a forest. But first of all, what is a forest? Let's understand the terminology of graph theory. A graph is a set of vertices connected by some edges. A tree is a graph having no cycles. Cycle is a closed path. That is something like this, a loop. Okay. So that is, we start from one vertex and we come back to the same vertex if we follow that path. That is a cycle. So a tree is a graph having no cycles. A binary tree is a tree in which each node has at most 2 children. So the name is clear, bi. Similarly, there are ternary trees and so on. So for a binary tree, each node can have at most 2 child. It can have 1 child, 0 child, or at max 2 child. It can't have 3 child. Okay. So a binary search tree is meant to make searching efficient. So that's why it's named contains search. So it makes searching efficient. Hence it is a binary tree. A binary search tree is simply a binary tree, but it is following some special ordering, some property in which its elements are specially ordered. So that property is something like this, like the left side element should be smaller than me and the right side elements should be greater than me. Generally that property is that. So that might be different. The definition of smaller and greater might be different in your context. For alphabetical ordering, this might be the lexicographical ordering, and so on. So a forest, just like in the real world, what is a forest? A collection of some trees, a lot of trees in fact. So it is a collection of trees. So this is one tree because it is not having a cycle and is a graph. This is another tree, this is another tree. This whole is called a forest. So this forest contains 3 trees. It may contain more trees, it may contain less trees also. Okay. So note that these are disconnected. So whole of this is not a tree, because a tree must be connected. A tree is a graph having no cycle. Sorry, a connected graph having no cycles. There is a slight mistake there. It's a connected graph having no cycles. So it must be connected. It can't be like this. So this thing is called a forest, which you are seeing here. So now that we have understood what a forest is, let us see how to represent it in a computer program. So we use a disjoint set data structure to do this. So this is one set, this is another, this is third. So this is a disjoint set data structure which keep tracks of a set of elements partitioned into a number of disjoint sets. Okay, so this is a disjoint set, this is another, this is another. So this whole is a set of elements, but it is partitioned into 3 disjoint sets which are non-overlapping because they are not intersecting anywhere. So we learned a new algorithm called a union find algorithm, which is used to perform following 2 useful operations on such a data structure. That is the disjoint set data structure. So find is an operation. Determine which subset a particular element is in. So let's say this is vertex number 5. So I might ask which of these 3 sets contains this element 5. So your answer should be this one, the middle one. So this is the find operation. Determine which subset a particular element is in. This operation can be used to detect whether 2 elements are in the same subset. So let us say 6, 7. So you might ask me 3 questions. Which subset is 5 in? So I will say middle one. Which subset is 6 in? I will say middle one. So you will conclude that 5 and 6 belong to the same disjoint subset. Then you will ask which subset is this 7 in? So I will say that the right disjoint subset. So you will conclude that 5 and 7 belong to different subsets. So that is the usage of this find operation in our algorithm. And another one is the union operation, which does the simple thing, join the two subsets into a single subset. So if I apply the union on left one and the middle one, then I will get a one subset. So this is a simple operation. So we will discuss how these operations are implemented and how we can implement them more efficiently in the further lecture. Thank you, friends.